This is a quick video to remind you how to do molar mass. I'm doing your homework problems 5 and 6 off of worksheet number 2, and that says moles to grams, grams to moles conversion worksheet at the top. To find molecular mass, you're looking at a compound, but you have to break it down into its individual elements first. So in magnesium chloride, I say that I have magnesium and I have chlorine. And then we have to acknowledge the atoms that are present in this compound. So in this compound, we only have one atom of magnesium. I know that because there's no subscript. And then we have 2 atoms of chlorine present in magnesium chloride. Then what you're going to do is you're going to take the number of atoms that are present and you're going to multiply them by the atomic masses that are listed on your periodic table. I know that magnesium has an atomic mass of 24.31 and chlorine has an atomic mass of 35.45. So I'm going to multiply those numbers out. 1 times 24.31 is 24.31. 2 times 35.45 is going to be 70.90. Then that's the individual weights of each of the elements in the compound. We want to know the total weight per mole of the compound. So we're going to add those numbers up together. 24.31 plus 70.90 comes out to be 95.21. But we never like to have a naked number. Those aren't allowed in our classroom. So we're going to do the number 95.21, and we're going to say it's grams for the mass part per mole for the molecular part. Box it in, and you're done with it. Now, number 6 is a little trickier because you have ammonium sulfate, but what you really have is you have 2 ammonium atoms present and 1 sulfate atom present. So we need to treat this 2 like a distributor, like a coefficient, and we need to make sure that we multiply the number of atoms present for N and the number of atoms present for H by that 2. So I'm going to keep up with the green, but we're going to list our elements first. Then we're going to count the number of atoms. Well, in 1 NH4, I only have 1 N, but since I have 2 ammonium atoms, I need to say 1 times 2, and that tells me I have 2 nitrogens. We'll do the same thing for H. So in one of the ammonium atoms, I have 4 H's. But since I have 2 of those atoms present, I'm going to say 2 times 4 and say that there's 8. Now there's no coefficients or no subscripts out here to multiply against the S and the O, so we'll just list them as we see them. S has no subscript, so there's only one of those. And O has a subscript of 4, so there's 4 oxygen present. Now we're going to go and find the atomic mass on the periodic table. Nitrogen's atomic mass is 14.01. Hydrogen's atomic mass is 1.01. Sulfur's atomic mass is going to be 32.07. And oxygen's atomic mass is 16.00. And literally, guys, I don't have a periodic table in front of me. I'm just pulling those numbers off of the internet, so you can do the same. So now we'll just be we'll be multiplying those numbers in our calculator. So 2 times 14.01 is 28.02. 8 times 1.01 is 8.08. 1 times 32.07 equals to 32.07. And then 4 times 16 is equal to 64.00. Now that we have the individual masses of each of the elements, we're going to add them all up so that we can get our mass of NH4,2SO4. So we'll say 28.02 plus 8.08 plus 32.07 plus 64. Add that all up together and you get 132.17. And don't forget your unit of grams per mole. Box in your answer and you're done with this section.